Good morning, friends. Today I am going to teach you about the scalars and vectors. Now, actually, what is scalar? Scalars are those quantity which we can express only in magnitude. And what is vectors? Vectors are those quantities which we can express both in magnitude as well as direction. That means, in short, in order to know a quantity, whether it is scalars or vectors, that means if we want to know about a quantity, then if we know only the magnitude, then we can know about that quantity. If we know the magnitude, then only we can easily know that this is a scalar. That means that quantity can be easily defined if we know the magnitude. But in order to know the whether a quantity is vector or not, that means if I say reversely, to express a quantity, we have to know both magnitude as well as direction. Without any of them, we cannot express, or we can. That means the vector, the definition of vector is not completed. That means definition of vector will be completed if we know both magnitude and direction. In the same way, definition of scalars will be completed if we know only about the magnitude. Now, I am telling you these scalars and vector quantities. Now, you may say, what is quantity? Quantity are those which we can measure. Those quantities which we can measure are called quantities. For example, length, mass, time, age. These we can measure. Those are called quantities. Now, I am asking you, suppose scalars. Example of scalars is distance. Example of scalars is what? Distance. Example of vector is what? Displacement. Now, what is distance? Distance is nothing but total amount of part covered by a body. Suppose a body is there, it covering a body is in A, now it is traveling to B. So how much part is covered, that is called what? Distance. So if we know how much part, that is enough. We can say that is what? Distance. But in displacement, we have to know two things. One is distances we must know. Second, direction. Distance means how much part it is covered. Besides this, we have to know about also direction, in which direction it is going. That means if we know only the distance, not the direction, that means if we know only the part, that is what? Distance. If we know both, then that is what? Displacement. So these two are called what? One is scalar, another is what? Vector. In a similar way, speed. Speed is scalar quantity. Velocity is vector. So in speed, suppose the speed of my vehicle is 40 km per hour. But in velocity, besides knowing speed, we have to mention direction also. For example, 40 km speed, 40 km per hour speed in the direction of west. These two complete will define what? Velocity. This will define what? Speed. Okay. Now you may ask me two things. Have you heard the current and time? So you may ask me, sir, whether current or time is the scalar or vector? Because Kirchhoff's law told you that, or any other law, it is current. What is current? Rate of flow of surge. And we know rate of flow of surge means what? Movement of surge from positive to negative. And you don't think that direction doesn't mean north, south, east, west. It means a sense. A sense. That means surge is moving from positive to negative. So movement of surge from positive to negative, that is a sense. You know where the surge is flowing. That is what? Current. That, so you can ask me, you are visible, that means you are sensing that current is what? Vector. Because current has magnitude. Suppose 3 ampere current is flowing and the charge is flowing from positive to negative. That means physically it seems that it is what? Vectors. In the same way, time also have direction. Suppose now it is 2 o'clock, after 2 hours it will be 4 o'clock. So it is also have direction. Direction doesn't mean only, I already told, direction doesn't mean north, south, east, west. Direction means a sense. That means after 2 hours it will be what? 4 hours. Okay, after 2 hours it will be what? 4 hours. So if it is 4 hours, that means it has magnitude as well as it has direction also, because you can sense after 2 hours it will be 4 o'clock. So it should also have been what? Vectors. But these two are not vectors. These two are not vectors. That means to define vectors, what we know? To define vector, what we know? A quantity is said to be vector if it has magnitude. Number 1. Number 2, it has what? Direction. Earlier in class 9 or 10 we know what is vector. A quantity is said to be vector if it has only magnitude as well as direction. But if we see the current and time, both has magnitude as well as direction, but they are not what? Vectors. They are what? Scalars. That means this definition is what? Incomplete. There must be something else which will add besides these two. That is what? To be a vector, number 3 condition is it must follow the law of vector addition. Number 3, it must follow the law of vector addition. That means now we can realize that in order to describe a vector quantity, we should know 3 things. Number 1, magnitude. Number 2, direction. Number 3, it must follow the law of vector addition. Now, what is physically, what is vector? Physically, how we can represent vector? We can represent a vector by like this. This is called what? Vector. And this is the length of the vector. And we know that a vector has two things. One is what? Magnitude. Another is what? Direction. This length is representing what? Magnitude. And this arrow side is representing what? Direction. So this is magnitude. This is representing what? Direction. Now since